Many other planets in our solar system have magnetic poles like the Earth. In fact, all of the gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have magnetic fields that are much stronger than Earth's. Mercury also has a magnetic field, but it is very weak. Venus and Mars, on the other hand, do not have significant magnetic fields. Planetary magnetic fields are generated by the movement of electrically conductive material inside the planet. On Earth, this material is the molten iron that makes up our outer core. As the iron flows and swirls, it creates a magnetic field that extends into space. The strength and orientation of a planet's magnetic field can vary depending on a number of factors, including the size and composition of the planet's core, the rate at which the core rotates, and the presence of other magnetic fields in the planet's environment. For example, Jupiter's magnetic field is the strongest in the solar system because its core is so large and its rapid rotation rate. Uranus and Neptune, on the other hand, have magnetic fields that are tilted at extreme angles to their axes of rotation. This is thought to be due to the presence of a layer of water ice in their mantles, which acts as a barrier to heat flow from the core. Magnetic poles are the regions where a planet's magnetic field is strongest. They are located at the ends of the magnetic axis, which is a line that passes through the center of the planet and is aligned with the direction of the magnetic field. The Earth's magnetic poles are located near the geographic poles, but this is not always the case for other planets. However, the magnetic poles of Uranus and Neptune are tilted at extreme angles to the rotation axis, and the magnetic poles of Jupiter and Saturn are slightly offset from the rotation axis. Many other planets in our solar system have magnetic fields and magnetic poles similar to Earth. These magnetic fields are generated by processes similar to Earth's geodynamo, which involves the movement of molten metal in their cores. Mercury has a weak but significant magnetic field. It is believed to be generated by a molten iron core, though it is much smaller and weaker than Earth's magnetic field. Venus, despite being similar in size and composition to Earth, does not have a significant magnetic field. The exact reason for this is not well understood. Saturn is another gas giant, and also has a strong magnetic field, though it is slightly weaker than Jupiter's. It is generated by similar processes involving metallic hydrogen. Uranus and Neptune have unique magnetic fields that are tilted and off-center compared to their rotational axes. These ice giants have magnetic fields likely generated by a combination of processes involving their icy mantles and conductive layers of water and ammonia. Magnetic poles are important in protecting a planet from harmful radiation from the Sun and other stars, and they deflect charged particles away from the planet, preventing them from entering the atmosphere and causing damage to living organisms. Further, it also plays a role in creating auroras, which are beautiful light displays that can be seen in the night sky. Auroras are caused by the interaction of charged particles from the solar wind with the Earth's atmosphere,